Hi, let's go ahead and get started. Welcome to the Nuclear Engineering Colloquium. We are proud to co-sponsor this seminar with the Nuclear Science and Security Consortium. If you haven't heard of the Nuclear Science and Security Consortium, it's a multi-institution initiative seated here at Berkeley. It's composed of 8 universities and 5 national labs, of which Sandia is a partner. And we're working to train the next generation of nuclear security experts, and we do that while engaging in research and development in support of the nation's non-proliferation mission. And so with that, we're bringing you this seminar, which will also be broadcast live to all of our students. So Dave Farley is a scientist from Sandia, and he works in non-proliferation and safeguards, and he's going to tell you about himself. Dave.
All right. Well, thanks for inviting me, and thanks for allowing me to come at the end of the fiscal year. We get our last data points last Wednesday, so any earlier would have been premature. And talking to Bethany earlier, it reminds me of this crowd when I went to San Jose State last year, where it was this mixture of people, and the feedback I got from that, they seemed to be more interested in my background than my actual talk. So maybe I'll give you a little background about me and how my path has been quite different than the normal path, and it might end up running for you as well. So I did my postdoc at Lawrence Livermore, actually, and I was doing the implosions on the NOVA laser, which is the laser before the National Mission Facility that we're now. And with an implosion, the main issue there is a mixing, hydrodynamic mix at the facility. So I was looking at that, applied both to nuclear weapons as well as fusion. After 3 years of postdoc, I said, I think I want to do something different. So the Electric Power Research Institute, EPRI, who you probably all know of, based in Palo Alto, they wanted to branch out more internationally, and I happen to speak Japanese, so they said, would you like to move to Japan and represent EPRI in Asia? And I said, when's the next flight? So I was there for about 5 years in Japan, another 5 years doing the same work at Princeton. And from that experience, I got really involved in the nuclear fission industry. I think I have about 30 countries I was involved with. And let me just say that the nuclear industry is a very global industry. It's definitely not US-centric, you probably know. Some of the things I experienced, for example, Kazakhstan. So as you may know, right now, Kazakhstan is the #1 producer of uranium. Well, that wasn't the case 15 years ago when I was there. So when I was going to Kazakhstan, they were number 5 or 6 in the world. And all the big players were in Kazakhstan. The Japanese were there, the Chinese were there, Ariba was there, we were there, trying to carve out how is this uranium supply going to get divvied up amongst the different nations. And Kazakhstan was deciding how that's going to happen as well. So I was meeting with the CEO of Kazatomprom, trying to figure out, as a neutral player, right, what they plan to do. And now they're number 1. Another story. Pakistan. I went to Pakistan a number of times. And this is post 9/11, and Musharraf was in charge, and we were giving billions to Pakistan for infrastructure. So I was there. Meeting with researchers there, such as yourselves, and meeting with generals, because generals run the show in Pakistan. Even renewable energy, that department was headed by a general. I had guys with AK-47s and from Kashmir who were guarding me because I got kidnapped or killed. So that was exciting. Another story. Indonesia. Indonesia, every 10 years or so, says we want to start a nuclear power program. So I went there and took a look around, and they weren't quite ready. But what I did see was the literal rusty lock on the reactor, right? So I'm in Yogyakarta, and here's a Triga with HEU in a pool of water, and it's literally a rusty lock on the door, and people wandering with no real controls whatsoever. So I've seen all of those things, and I could keep going with more stories. Then I came back to the national labs and started writing proposals, such as this one, that are a little different than your pure science sort of proposal, where I'm going to do this very narrow scientific study. I propose sort of different ideas which seem to get funded, and then we figure out how we're going to actually do the work. So this work is called cognitive computing. That's a word coined by IBM for Watson. So when you hear cognitive computing, it generally means Watson, and people who are not Watson get a little angry when you use that term. You can replace that with text machine learning, if you like, but I'll be talking about Watson primarily here. So how did this start? So 2 years ago, 2 summers ago, I was invited to New Mexico for this brainstorming session. No managers allowed, just scientific people. They put us in a room, and each table had 4 people on a table, a bunch of tables, sticky notes for each person, and you had 5 minutes to write down every crazy idea that you can think of for non-proliferation or whatever the topic was. So we're writing out all these sticky notes, right? And then at the end of that, you collate your results and pick your table's top 3 of everything. So I had a bunch of bad ideas. But one of the ideas I wrote down wasn't quite this. What I wrote down was, what if we had an IBM Watson and we trained it to design a nuclear weapon? What would it do? We give it every manual we've got, every physics book we've got, every classified document we've got. Give it Alibaba, everything on there. Give the nuclear suppliers group list of what they shouldn't have, right? And let it go. What would it build? Would it build something useful or something that just won't work? Kind of a Monte Carlo simulation of what would it build? Well, when I pitched that idea, I actually got laughter from the rest of the table, and that's crazy. Well, the Manders caught wind of it, and they said, actually, that's a pretty nifty idea, but let's change the cyborg, destroy the world part of it, and let's make it a non-proliferation analyst tool, like an assistant. What would that look like? And is that useful? So that's what this project morphed into. I was given some money the first year just to look around and see what's out there. Because I had said IBM Watson just because of the name. I didn't know if it was the best thing. But I looked at Google, I looked at Microsoft, I looked at startups around here, and I just couldn't find anything competitive with Watson. And I hired people to go look also, so it wasn't just me. So eventually I said, well, let's call IBM. So I picked up the phone. I found on the website for Watson a phone number, and I called it, and some guy says, hello. And I said, yeah, I'm from Sandia Labs. I'm interested in Watson, and how would I go about finding more? He goes, I don't know. We don't deal with the national lab. Can we find you somebody? Days and days later, multiple phone calls, I find this guy at IBM. And remember, back then, 2 years ago, IBM was just rolling this out, Watson as a commercial product. Jeopardy was a big success. That kind of culminated in 2011. They had to unbundle all that and make it a commercial product. It wasn't until a couple years ago when they really started ramping up sales of this thing. So I caught them in the middle of all that. And here's a very large potential customer, the United States government, DOE, who's calling them. Right? So we had them at the Sandia. They gave a talk. It was a full house. And from that, I got more money. And last year, I had what we call an LDRD, which is an internal slush fund for research that we choose what we want to do. So mine was chosen for that. And I'm going to show you the results of my study there. There's one more piece. So as I'm calling around, just trying to get info about Watson and how to get a copy and what does it do, I get transferred to various people, and they say, hey, you know, there is a federal Watson system already in existence that not many people know about. It's unclassified. No. There's a very large system at 100 million documents ingested, and we could probably get you a seat on it if you. So I said, well, that sounds pretty nifty. It ends up, it's for the intelligence community. It's all classified reporting. It's unclassified that it exists, but it's classified if you're on it. You have to run a credential. And luckily, I have a credential, so I got some seats on that. And I'll tell you what I did with it. But basically, I got 25 seats, and I distributed them among 7 national labs. I said, let's test drive this thing. Ask it whatever you want, and let's see what happens. Right? So one question, I don't know if you can read that people would have at the national labs was, well, wait a minute, IBM, this is going to be a black box. We're not going to know what's inside it. We're just going to pay them money, and now we're stuck. So we wrote an NDA with IBM for them to open the box, essentially, for us. So we can know what's going on. And likewise, we can tell them, hey, these are the types of things we're worried about. Is this even a good fit? And so they've been interacting with us for the past year based on this NDA. So what is Watson? First of all, contrary to the commercials, all right, Watson is not this end-all of everything for analytics. Watson, the one that gets advertised, is supposed to be a text analytics tool. It knows nothing about structured data. It can't take sensor data. It can't take image data. It doesn't know what to do with anything. It is a text analytics tool, a question, answer, hypothesis tool. But based on the very good success of Jeopardy and Watson Oncology, if you've heard of that in 60 Minutes, for detecting cancer, been very successful. So IBM is rebranding pretty much everything. It's called Watson now. They have Watson Education, Watson Oncology, various names, even Watson Law Enforcement, right? So Mitch and I were at this thing last October. I go to Watson Law Enforcement, and they have all these cameras on the policemen, and they're doing biometrics as they're walking around. It's called Watson Law Enforcement. So I talked to the guy and said, well, what's this Watson Law Enforcement? He said, well, yeah, we're taking these video images, and then we send it to the Watson. I go, wait a minute. Watson's a text tool. It's not an analytics tool. But yeah, technically you're right, but we're calling it Watson. Right? And so what they actually were doing with that is they had deep learning, right, which is a state-of-the-art technique for imagery, and they're just calling it Watson. So you have to be a little careful when they say, we've got a Watson system, because it should mean text analytics. So this is what Jeopardy did, and the version they have now is a vanillized version of this. What they do, they take your question in English, they break it down, they parse it, okay, to get meaning of what your intent was with that question. They then run in a massive parallel way your question against all kinds of possible answers. Now these answers are based on these models, and there's about 100 models, proximity models, how close in time, how close physically, other models that have been weighted by all the reading and other techniques it's done. So when it sees your question, it parses it out, it runs it in parallel to all these models over here, and it starts developing what they call hypotheses, which means that Jeopardy answer, right, the 1 or 2 word Jeopardy answer, as potential answers, runs it back through and says, well, how do we score that answer compared to the rest? And after doing that many, many times, it comes up with a ranked list of those Jeopardy answers and the supporting documents to prove that these answers are correct. That's what it is, right? It's state-of-the-art, it's massively parallel, and it's brute force, right? It is not Google TensorFlow, it is not these other tools. It's their own doing, and this is basically how it works. The challenge they had after Jeopardy, which is 2011, was Jeopardy is, when do I chime in for the question and how often am I right? Now for a Portuguese bank, which is one of their first clients, when do I chime in isn't really what they're after, right? So they had to make this a generic model, which was a whole research project in itself. Now they have this sort of vanilla version of Watson, and they go to any domain, ingest that data, and now it's Watson for that thing, Watson Oncology, Watson for Portuguese bank, whatever it's going to be. The newest thing they're doing is they found that taking documents in a foreign language and translating them into English doesn't work very well. What they've done is they have a Japanese version of Watson that's in Japanese. The code is in Japanese, right? There's one in Portuguese. I think Russian's coming, Arabic is coming. But they found that the nuance of language is important, and they can't just translate into English. It doesn't work well. So that's what they're going with that. I'm showing this from one of their papers about the Jeopardy project, and this is my red arrow. When the guys in 2007 first pitched this idea to IBM and said, hey, I think we could build a computer that can beat Jeopardy, right? They did a quick test. This percent of questions answered in Jeopardy, this is how often you got it right. This first black line was day 1. Not very good. The dots at the top are the human contestants who usually win. We had to meet that before going on TV, right? So this training here is training that Watson, developing the algorithm until they were confident, back over here, April 2010, that they were ready for the show. Now, why do I show that? I show that because, as you'll see from my results, it's a mixed bag. Watson is not this great thing, at least for non-proliferation. Why is that? The reason for that, I believe, is because we're down here with it. We're not up there yet. And to get up there is a major effort. So let's get into that. So the test drive. What I did, I took these 25 Watson seats that I had. You had to have a clearance to get on it. I found 25 people from 7 national labs who were willing to take part. We had Sandia, and 7 more Pacific Northwest, Flannel, Argonne, Kansas City, and Oak Ridge. All had seats. And what I asked them, I said, ask away. Ask your questions of Watson. Make sure you keep it within our classification zone, because we don't want to cause ourselves trouble by asking classified questions that shouldn't be asked. But rank how Watson does. So this first part here was, did Watson even understand your question? Did it get it? It's pretty obvious from the result whether it even understood what you meant. 1 means no, the red bar. 3 means yes. So as you can see, it's a mixed bag. Sometimes it really got it well. Sometimes it just didn't seem to get it at all. Right? The next one was these Jeopardy answers. How good were those? Same problem. A lot of bad stuff, some really good stuff. Okay, and then with that, the documents offered to you to read, how were those? Were they excellent or not so good? And again, a mixed bag. Right? Now, I'll tell you, because I was on it quite a bit, when it was right, it was shockingly good. Right? You would ask it something like, what is the range of country X's ballistic missile? And it would come up and be spot on within the claim. Right? When you ask you a different question, it would say like 10 millimeters, which is nonsense. And it wasn't clear why was it doing that. So from this, people had a mixed feeling, right, of Watson. So here's something else we did. Let me explain this a little bit. When I first proposed this LDRD, the proposal was, we're going to ask it questions. We're going to see how it does, like the previous slide. Now we're going to train it in that domain, non-proliferation, and ask the exact same questions again, and see with the training, does it now do better? The LDRD committee decided they didn't like that halfway through and changed my project into, let's quantify it better than the previous slide, right? The claim was, it's too human-centered, it's too subjective. It's good or it's bad is a human judgment, right, 1 to 5. They wanted something more of an equation, a differential equation, something in there to justify this Watson versus Boole competition. It ends up that you can't take the human out of it. You just can't. Right, so what we did here, and I'll explain why the human's still involved. We try to take conventional metrics like R positions, recall. You'll see that a lot in studies of Google, that sort of thing. And this is called the normalized discounted cumulative gain, which is a classic data analytics metric. Just to basically tell you what it means. If you asked a question of Google and you knew the top 10 answers, right? You just knew which ones were right, and it gave you its results. If number 1 is down here, it got number 1, but it was number 5, there's a penalty for that. Right? That's the discounted part. If they got them all right perfectly, you'd have 100% ranking. But it ends up, they didn't quite get all of them, and then they're not in quite the right order. Right? So that's what this is. In blue is what Watson did for some questions. In red is what a Boolean search did for those questions. And you can see it's about 50-50. Sometimes Watson's better, sometimes a straight Boolean search is better. Okay? But again, it hasn't been trained. It's just raw Watson non-proliferation. Now, another problem that came up, and this is the human part, is these tools that Google uses and other Amazons use, they're using millions and millions of user clicks and hyperlink clicks and their phrasing of their questions to derive this data. And they have full access to all of that data. We don't have that luxury, right? For non-proliferation, if I ask a question like country X's ballistic missile, there aren't a million clicks on that, right? Especially on the classified network, they're not. So how do we how do we evolve that metric to take into account this very sparse data that we can compare now in an apples-to-apples way with Google? The only way we can do it is we ask a question of Watson, we ask a question of Boolean, and I physically read every single document and rank them myself and my comments. So we sat there for 6 months asking questions, seeing what the answers were, reading them ourselves and saying, well, this is actually number 1. With number 6 on Watson, there should have been. And here's what our Boolean search did, it should have been here. And that's our mini corpus for that question, and that's how you do this ranking. That, too, is human-centric. That's me judging which one is number 1 and number 2. You can't get away from this human aspect of it. No matter how much the LBRD committee might want it to be objective, it's just very hard to do. So looking back on it, we should have done what I originally proposed. Let's train it and see if it got fed. Because now, yeah, we got this cool metric, but we don't know if training would have made it better. We just don't. Let's go to some conclusions on that part. There's more to this talk than that. But what we found is, whether you like Watson or not, if you like TensorFlow, which is really gaining strength these days, there's going to be this training required. You cannot avoid that, right? There's no magic unsupervised learning bullet here. So the Watson I was on has read 100 million documents. That's unsupervised learning. For those 100-odd models, it weighted those models based on reading these documents. There's no human intervention. That's it. And it got about 50% compared to the Boolean, right? The other 2 ways to train Watson, you give it a dictionary of your terms. Uranium 235 is this, right? It doesn't have that. PWR means pressurized water reactor. It doesn't know that. Okay? The best way, you take SMEs like us, subject matter experts, and we sit down and we write 500 to 1,000 questions with a correct answer. And we feed that into the system and we say, these are true question-answer pairs. Weight your models based on these in priority. When you do that, IBM says you get about 85% accuracy after that. That's our experience with all these other customers. The question is, who has a tolerance for 500 to 1,000 question-answer pairs, right? And when you talk, now if you're talking about something Google-like, maybe that's possible. When you're talking about people like me, and there's probably on the order of 100 of us that be willing to do this across the country, it becomes an effort. And somebody has to put a stamp on that and say, we want to do this. Right? And right now, we're not quite there. The second bullet, we've come across this a few times through this journey of conferences and giving talks across the labs. I visited several labs and given this talk before. Sometimes the computer science folks feel like we're trying to take their jobs from them. And I say, no, we need you because I don't understand all of this scripting that's going on. JSON, that's not my thing, but you guys know that. So we need you. But we've also found, and we've done this directly at Sandia, we've hired a whole bunch of computer science people for cybersecurity. We've tried to convert them into nuclear engineering systems people. That doesn't go very well. You can't train a computer scientist to be a nuclear person that quickly, right? So now we're leaning towards a partnership, or maybe take some physics-oriented people and teach them the data. But that might be easier to do. People say, okay, well, why should we put all this money? If the question-answer pair seems pretty arduous, I don't know, it's a lot of money. Well, we do have some data points. So Watson Oncology, if you saw that 60-minute special, is identifying cancer as good or better than the doctors say. That works. I don't know if Mitch went to this talk in the big auditorium at World of Watson, but they brought up this Tokyo University professor who, in broken English, told us about how there was this lady dying of cancer. She had weeks to live. Nothing was working. They had just gotten their Japanese version of Watson. They plugged in her diagnostics, her profile. Watson came back and said, you misdiagnosed her. This is what she actually has. Here's the best clinical trial for that disease. She was cured with it. So we have these data points, right? But we don't have the investment yet. The Watson Oncology was not a trivial pursuit, right? Another conclusion, unsupervised learning, just reading those documents, it's about as good as Boolean. So that's kind of good. The other thing we found, and you'll see later in this talk why I use that, the phrasing of your questions seemed to change the answers. The things you wouldn't think were a big deal, like manufacture versus produce. Where does North Korea manufacture its uranium, for example, versus produce its uranium? Give you wildly different answers. But to us, it's the same question, right? So what I would have been saying is, some of these tools we're developing will get out of my hands. And I'll end up in a non-technical analyst back east who doesn't know what question to ask, right? A fire would say, what is that? Right? How do we assure that they're going to type the right question? Even if you kind of know the question, if you phrase it a certain way, you're going to get dubious answers. So those are the initial results from that. So from that, and this part I'm including because I think anywhere where we say San Diego National Lab, you could probably insert Berkeley instead and have the same sort of qualification. People say, well, what's the value added of this thing? Why should we pursue this at all? And so I came up with a few things. One thing is this Jeopardy-like feature, where you just get the answer instantly. If you have confidence that it's right usually, that could be useful. The actual number of documents. Watson gives you 25 documents and it stops. Now, we all do Google. How many pages do you go through before you stop? There are no second pages. So if it truly got 85, 86% accuracy on that first page, so that you knew you could stop with some confidence, there's something of value in that, right? How do you know your Boolean is right? Right? Another question I'll throw in there. I would write something in English, like, where does country X manufacture Y in this year? How do you make that into a Boolean? Country plus, it's not clear. And so I'm not sure my Boolean's even right, right? We also found regularly that the Watson results and the Boolean results were different. Fundamentally different documents. They might come to the same conclusion, you read them all, but the actual documents themselves were different. Then you go, well, wait a minute, I've been doing Boolean forever. Have I been missing all of these? Another thing, the fourth one is foreign language. So non-proliferation, there's a lot of things in Russian, for example. There's a lot of things in Chinese. And we have translators, right? But if I hand them 5 pages of Google search, that's not happening, right? If I hand them 10, well, that's digestible. If we had confidence that those 10 in that language were the top 10, that we can routinely do, right? With some confidence. Use cases. This is the healthcare one. This is the Watson Oncology. Autodesk and Knowledge Discovery, they're all using Watson to try to improve medical outcomes. Okay, why don't I skip this one? So here's what we've identified as our top targets for getting funding for this Beyond Lab project. And again, I'm thinking Berkeley could easily be in these categories as well. So for nuclear weapons, we literally have file cabinets of things in 1945. We have a huge influx of young people who weren't around in 1945, right? Yet we have billions of dollars in life extension programs on nuclear weapons stockpile that these young people have been tasked to go fix. And we don't even have it online, right? Much less ingested and available to clear. And they have a lot of money. So NA10, that's the group at NNSA. We're working this angle heavy to find out, can we get some investment money to tackle the nuclear weapon knowledge data problem? Not going away. Non-proliferation, this is NA22 in the intelligence community. There is no person alive that can read the sheer volume of reporting coming. You just, right? The Watson can, or a platform like that can. You can read everything and remember everything, right? And humans don't scale. That's the problem, right? We're getting more and more data. People are adding imagery, all kinds of things, and there's no way we can ingest all of that. And then nuclear energy. So the BWR and PWR owners group are screaming, saying we want this stuff yesterday. They are dying under operational costs, right? A shutdown and trips of reactors is killing them. What their dream is to have a pump that's reacting badly, with a classifier that says, hey, I'm reacting badly, and you go replace that pump before it was supposed to be, because you're now avoiding a trip. Right? The operational costs go down. They're screaming for that. And EPRI, where I used to work, they are now mandated this year to make a roadmap of how they're going to tackle this problem. Next year, they'll start actually doing it. Right? So everybody's getting on this boat. No one's quite sure where the boat is going. And people like me and people like you are the ones that are probably going to determine how it goes. Nobody is quite sure. So, how might this work? Maybe you might have the sort of cognitive computing aspect. Maybe it's Watson, maybe it's Google TensorFlow, I'm not sure. But you have this. This is the text tool. Above that, you have all the structured data. It might be nuclear power plant data. It might be imagery from satellites. This arrow coming down connecting doesn't exist right now. It's an unsolved problem. How do you take structured data, like vibrating pumps or an image from a satellite, and make that into a contextual question for cognitive computing? Nobody knows how to do that. IBM's working on it vigorously, but they don't have an answer yet. Right now what they do, IBM does, is they take incoming data, like for a cyber attack, they automatically pull out the IP address that cyber attack came from, and they say, in English, what else is happening at location X? And it automatically goes into the Watson database and pulls back that answer. That's kind of a Band-Aid approach. The real approach should be, how do we make an algorithm that ingests both things and gives you an answer based on both? Maybe provides both. That's the dashboard. It's an unsolved problem. You can imagine that for nuclear energy, non-proliferation, nuclear weapons, all over the same platform. One reason I write this slide is people say, oh, we got to buy multiple Watsons for every mission. That's going to get expensive really fast. Actually, no, you just buy one, and you train that brain separately. They point it to certain data, and it will learn separately on that data. So, for non-proliferation, one dashboard is just an idea. Maybe you have a pane here, a quadrant that's kind of a Watson quadrant. It automatically brings up some relevant documents. You can always ask it questions if you want to, but maybe it brings up a map with some hot spots from overnight. Maybe there's a tutorial that you click on. You want to learn more about that topic. And maybe there's a network diagram about who knows who. That might be useful. We don't have that now. Now there's this idea that came up of, well, wait a minute. At the National Lab, we have SRD data, nuclear weapon data. This federal Watson system that I've been on does not have that. It's not accredited for it. It will never have it. So we can't use that Watson for the nuclear weapons stuff. Wait a minute. So what are we going to do? Well, IBM says, well, we got this public cloud. You guys interface with the public cloud. No. There'll be no public cloud for the nuclear weapons people, right? So that's off the map. So what do? Well, you can make a private cloud, make your own Watson. Well, that becomes very expensive very fast, right? But the cloud model, that might be fine for nuclear power. As long as we have PKIs and encryption and that sort of thing. Safeguards, IEA, that might be adequate, a public cloud sort of infrastructure. So maybe there's sort of two realms here, sort of a classified Watson or cognitive computing, and maybe an unclassified version. There's the same people working on both systems. Uranium-235 is the same, right? This is from IBM. Again, this is because some people get a little frightened that IBM is going to take over, right? And so they're saying, no, we don't want to take over. We want to give you one component, then you build around that. So this is Watson, they're saying. But all your other things that you do, all your analytics, all your predictive modeling, that's yours. We're just that text tool. And we're all API'd. You can API to us as much as you want. So that relieves some pressure on people thinking that IBM's going to own this whole thing. Or they just have a portion. All the rest of it, like that structured data problem, they're not going to do it. That's for us. So this is sort of my summary of that portion of it is, take that same platform idea, pick whatever app you want to do, nuclear weapons, energy proliferation, human resources, they can use it too. Get a team together of data scientists and subject matter experts that sit together to sort all of this out. And maybe something like this is the flow chart for each one of these missions. So this is a little provocative. This is something I came up with. Remember I said, maybe we should take the question asking out of the hands of people, right? So what I said was, well, what if we made this visual? And everything is touch and click, right, on your phone and so on. Maybe this typing of question is archaic. What if we made a pie, and by clicking on what you're interested in, it'll automatically bring up that dashboard already pre-populated with sort of the answer at the start. So here on this third of the pie, I'm putting in weaponization with the Sandia side. You got firing sets, you've got neutron generators, all those different things. On this side, you've got the special nuclear materials, Oak Ridge and so on. This is highly enriched uranium, plutonium, those sorts of things. And the upper third is the physics labs. It's the radiation transport, those sorts of things. The inner circle there would be supply chain, right? Most of these countries need a supply chain to bring this stuff in. The middle one would be a skilled workforce. Follow the people. Somebody has to do this work. Who are those people? What's their background? What's their education? Right? And then the outer ring would be applied R&D. This is actually going out and doing a hydro test. Who's doing that? So what you would do for every country would have one of these pies. Let's say this one is North Korea. And based on our assessment, how close are they to any one of these technologies? That could be programmatic money, where the intelligence community says, yeah, here's a bucket of money, just keep that updated, will you? And then their analysts can just click on any of these, and if any of these get close, with like a warning red light, they can click on it and see what's going on. So some people have seen this and get kind of excited about it, that it could be this longer-term vision of what data analytics might be for non-corporation. So shifting gears a little bit, you know, at Sandia Livermore, we have this open campus. I don't know if you've been out there. We have some acreage adjacent to the lab that's supposed to be for commercial use, where we get partnerships coming to the lab. It's been going on for, I think, 15 years. We're still not quite bringing in the outside investors. So people say, well, Dave, can you think of a way that we might use LVOP, is what it's called, for this? So I said, well, I don't know. What if we had this SRD Watson, nuclear weapon-based Watson, and tie it into the federal Watson through API calls, right? So we're covering that side of those classified reporting that can't be found any other way. And what if we had on the open side of the fence, so the nuclear power version of Watson, for example, that's unclassified. Like I said, uranium-235 is the same, either way. The same folks just walk 100 yards between both sides, right? Now, if you did that, maybe you base that Watson at IAEA headquarters in Vienna. And you say, hey, everybody, this is free, but you got to play. So, dear China, if you want to play, you got to put in your data. Japan, you want to play, you got to put in your data. And you have full access to that Watson if you want, right? We get all of our labs doing the same thing, Argentina, Brazil, all involved. Now we have this huge corpus of nuclear data and operational history that everybody can share and learn from. You got a pump that's vibrating funny? I'll bet somebody somewhere had that same problem. Now it's instantly available, right? I think that's the sort of power that this tool could be, beyond me and 24 other people asking silly questions, right? There could be a much broader scope. So I'm going to go back. This is the end of my sort of Watson journey for the year. The project ends in 2 days. I've been funded for this blockchain project starting in a week. But are there any questions about this part before I jump into that? Do you want me to jump into the blockchain? Maybe we'll do blockchain. The idea here is, you've all heard of blockchain and Bitcoin. So Bitcoin, which is in the news a lot, is this completely decentralized network of nodes. So the idea is there's no authority in charge of Bitcoin. If you have the most computing power and can mine the latest Bitcoins, you win some Bitcoins, and there's this decentralized node confirming all the hashes around the world for whose transactions are valid. That's not what I'm suggesting here. Here, I think you would need what's called a permission ledger, where there is some sort of authority. Somebody's in charge, right? Even Bitcoin, when there's a glitch and something goes wrong, somebody who's been designated as the authority goes in and fixes it, right? If you volunteered for Bitcoin, go in and fix the problem. So somebody's sort of in charge, even for Bitcoin. Here, IAEA would be in charge, okay? And the idea is an open ledger. So when the IAEA does an inspection of a facility, they actually go in and look at the books. Say, okay, you say you have this much uranium, this much plutonium, show me where it's at, right? And then they're just verifying the books, literally, right? Well, what if that's all in the open? What if it's all on a blockchain? So as that country updates its ledger, it's available to everybody, including the IAEA, right? That's the idea. So maybe country X gets a certificate from the IAEA to be a member of this blockchain. Maybe IoT, right? Internet of Things. Maybe these unattended monitoring systems, maybe they are adding to the blockchain. Hey, I just saw this. I just saw this in my camera. And it goes into the blockchain, unerasable, right? And then these nodes, the verifying nodes for a blockchain, these might be all the different countries who are interested to make sure everybody's on the up and up, right? So the IAEA and DOE have expressed quite a bit of interest in this topic. If it was to work out, I think it would be game-changing for safeguards. You imagine not as many inspections, everything's instantly populated, everything's completely viewable by everybody. There's no he said, she said business. One thing that's interesting about it is the algorithms I've been looking at use this Byzantine fault tolerance. And basically what it means is if you can promise that at least 2/3 of your nodes are correct or working properly, you can guarantee security. If you have 1/3 of your nodes are bad players, that's okay, as long as you have 2/3 plus 1, which is achievable, right? You have enough nodes to cover 1/3 being bad, and you're guaranteed that this will work. So here's the example. Let's say the answer is supposed to be ABC. You've got just a random error, DEF, and you have a bad player. Well, you keep doing this node process, you convert the DEF to the correct answer, and you just discard the bad through this Byzantine process. It seems to work, but similar to the Watson idea, this is all on the ground level right now. Nobody quite knows where this is going, Watson or blockchain. But it feels like it's going somewhere. And right now, Sandia, Berkeley, and so on, we seem to be at the ground floor and can direct where this stuff is going. Right? So I think that's all I have, and I think we're out of time anyhow.
So it was my understanding that countries with safer agreements didn't want to have unintended monitoring systems that were automatically conveying data to that. So it wasn't so much a technology in terms of the internet tech capability, but that countries did not want to allow that type of technology.
Right. So there's a political element. There's also proprietary. People don't want to be wandering around seeing it. I think at a minimum, it could be their ledger, and maybe we don't have access to their ledger. So if you could prove to people that your data, even if it's IoT, is encrypted, right? So you can't see the data, but you can just you can verify that it occurred. Might be acceptable, right? If somebody tried to hide something, there would have to be an event of hiding. It might not tell you exactly what happened, but something happened, and it's been recorded. You can't, so as you know, there's a tamper problem in safeguards. How do we guarantee that these things happen? Well, at a minimum, blockchain prevents glossing over tampering. So if something happened, blockchain was recorded. Maybe you don't have access to what that was, and maybe that's acceptable. Okay, we're willing to say that the camera triggered, but we don't want you seeing it until you come visit, or whatever the agreement is. So yeah, this is new. Not sure how this is going to play out. Let's see.
So currently, Watson is. It seems like it's like a searching current data. What kind of that already exists? What kind of are there efforts to go full minority report for Skynet and do like predictive, like trying to predict future actions? Let's say.
Yeah. So okay, so the way we're just talking about Watson. The way Watson works, it wants a confined database, so it doesn't web crawl, right? And if you guys all know the Microsoft bot story, right? So Microsoft tried to do their own thing. They turned it loose to the internet, and one day it became a ranting racist, just yelling at everybody. And the reason, because the internet is biased, right? So IBM is very careful to tell you, don't just turn this thing loose, right? Because once it learns something, it doesn't unlearn it, right? So you can't do that. But what they are doing, DoD has something called the third offset. You heard about the third offset? But the first offset is nuclear weapons. Second offset is precision-guided munitions. Both of those put us an order of magnitude above the competition. The third offset is supposed to be this sort of stuff, where we can outmaneuver, outthink the enemy before they have time to react. So what they're working on is just what you said, predictive analytics. They're trying to say, we're going to be on all the time. We're going to have these predictors, and if something bad's about to happen, we're going to flash that up for you. But that's in R&D.
I understand the value of Watson for the problems you talked about. One thing I'm interested in is you talked a lot about needing to evaluate the results after a few test runs and then recalibrate. And you found some weird artifacts, like just the difference between synonyms, but interpreted differently by Watson. What about the efforts to put something like a filter in between the question and what actually gets fed into Watson, so that the handling of how the question is asked is not done by conscious humans, but by some, module that you design?
Yeah. So the Watson I've been on was prescribed by the sponsor to IBM. Thou shalt make it look like this. So it literally looks like a Google search bar. IBM says there's a whole lot more we could do beyond allowing somebody just to type something. So what they suggest to do what you're saying, there's these API calls you can do now to it. So for 50 cents a call, you can have your own Python code, and maybe you have an automated way to populate questions based on something you're seeing in a nuclear power plant, for example. It populates this PDF file of questions, and that gets API'd to that machine or their public cloud, right? It doesn't have to be a classified machine, and do what you want with that data.
What scares me, or what's a little weird about using this for something like nuclear weapons or something, is that what if it becomes really good at giving you an answer that's convincing, but still not right? And because you're always just kind of processing it to look more like a correct answer, it ends up giving you something wildly off that actually has an effect. Because if you don't inject some real check of like physical consistency, I guess, I'm just that person who's like, oh, she's really scared.
Right, right. Well, I think no one's saying that Watson will become an analyst. It's supposed to be a tool. So it recommends the top 25 documents. They expect you to read them, not just say, hey, it said this, we better attack right now. It's not supposed to be like that.
It's a variation on the same question. But cognitive to me means thinking. A equals B and B equals C then. Whereas what Watson is doing seems to be very, very sophisticated data search, When you say train, all you mean is you're broadening the search algorithms, broadening the database. You don't mean what neural nets do of actually adjusting the way you do the computation. Am I right? I could be
I would
wrong.
say the answer is in between those. So deep learning or a neural net is not Watson.
That's okay.
Okay, so the deep learning, neural nets, whatever the lingo that people are using is, that's we have these blind nodes and you feed it a bunch of data and then out pops this magical answer. And today, nobody knows why those neural net deep learning work. Nobody knows why they work. They just do. That's true. Watson is not that. Watson is prescriptive models that they found seem to lead you to the right answer. Proximity in time, proximity in space, other semantics that they combine and say, hey, these models from Jeopardy seem to work.
But the right answer has to have been found before. This doesn't generate a new
No, it's not oversampling. So oversampling would be that you trained it so well that it's going to give you 100% accuracy because it's going to ignore other things. And they don't want to do that. So that's why you do 500 to 1,000 question answer pairs. They say that's enough to weight it sufficiently. So now as it learns more, reads more, it's still open-minded, but it's thinking better, if that makes any sense. Where if you gave it 10,000 question answer pairs, now it's only going to look for this answer because it's 100% right, it has to be this, anything else is chaff. So for example, when I asked one of the intelligence agencies to partner on this, their suggestion was, pick a topic that nobody's looked at before. For example, if you pick Iran as your topic, well, guess what? They're already guilty, right? If you look at the reporting, just the tone of the reporting, they're guilty, right? Whether that's true or not. So when Watson reads all that, it's saying, yeah, well, Iran, obviously it's guilty. So no matter what you ask, it's going to be slanted, right? Whereas if you pick a different country, like Japan or something, maybe that's objective enough where you can do my sort of study and decide when do you stop training. But my point was, right now, we don't know when you stop.
It seems like one of the relevant points about Watson is that for the answers, it provides a set of data that it used to draw those answers from. Are there ways when you're thinking about like politically how to do these decisions, you can take the top 3 answers and then a human actually look through the data more clearly? It goes as opposed to a neural net where you're like, oh, magic.
Yeah, magic. So you can, of course, read the documents. There's a hyperlink to the document directly. If you have the right credentials, it will pop up. What you can't do in this instance is look at the weighting fact. Like, for example, IBM had a good example. They said, if our weighting, if the sponsor allows to show you the score, right? If you saw 98% and then 80% and 20%, you've got very good confidence that we've done it right. If you saw 22%, 21%, 20%, it's probably all kind of nonsense. But they don't allow you to see that.
I see.
So you can read the document for yourself and say nonsense or great. The sponsor was very dictatorial.
The product itself, Watson export control, who could make a procurement from IBM? Because this, as you say, this is the third pillar of the product.
Yeah, it's tricky. So IBM doesn't own any of this data, right? They own the algorithm for mining the data, right? If I was an export control for those multiple labs, so I was dealing with all these, who should get what? I think it's not clear yet when you draw the line when machine learning becomes export control. But the data, IBM says that's not us anyhow, right? So we're just sending algorithm to you. We're sending you MATLAB. So is MATLAB export control? It might be in certain countries. So I'm not sure where that, I don't think anybody knows. So,
Seems to me they better figure out this horse there that's the barn.
Maybe another way to think of it is some transport codes, export control for like the fundamental nuclear data.
Right.
So let's thank Dave again.